Welcome to Slight Reliability, the show where we learn SRE and observability 1 week at a time. I'm Stephen Townshend. Welcome back to Slight Reliability. I'm Stephen Townshend, and this is the show where we learn about SRE and observability 1 week at a time. Today on the show, I'm joined by Sonja Chevre from Tyke, and we're here to talk about bad API observability. Just a little bit about Sonja. Sonja is a product manager with more than 20 years experience in tech and 10 years experience as a product manager for various tech companies. She comes from Switzerland and she moved to Austria quite a while ago, and she lives there now with her family. She recently started describing herself as a full stack product manager because she likes to jump on new topics, no matter if they are very technical and working with engineering teams, or if they're creative and working with marketing and the UX teams. And she's a fan of working in public, sharing and learning at the same time. And that's why she's excited to be on the podcast today. So hello, Sonja. How are you today?
Hi, I'm good. Thank you. Yeah, that's true about the podcast because you're also in the same spirit, right? You're learning in public and learning as you go and sharing and getting feedback. And I think that's the best way of learning.
I think so too. There's something about if you're going to put yourself out there and say something, it forces you to like reflect and think about, what does this all mean? And then how does it work? I get a lot of that anyway.
You can be there. And here I come with my expertise. This is what I see. What do you see? And it's easier to put yourself out there if you come from that perspective of learning and sharing with the community than being the one who knows everything and has to tell and wants to tell everyone.
That's definitely been my experience moving from performance engineering, where I felt very confident, to SRE, where I feel like a complete beginner still after a couple of years. But that's okay, right? You can go out there and say, I'm just learning some stuff. Let's learn together. Did I miss anything in your intro that you wanted to share about yourself?
No, that's great. So yeah, I really love tech. I started as a software engineer, but then saw that I wanted to have more impact, not more impact, but being able to make more decisions and also switch from one topic to another. So I'm not good at just staying on the one thing. I really love to take something, improve it, and then go to the next one. And product is a great way to bridge technologies with users and understanding what they need. And yeah, that's drives me to see how we can make things better for users.
I used to work for an organization where there were lots of product managers, but they didn't seem to be really helping with anything. It was so weird. It was like they were more like managers or project managers who were like dictating timelines and things, and as opposed to being that conduit to sort of connect together the engineers and the customer and the business. It was completely missing the picture. Yeah,
that's the problem with all product management. So that has also evolved a lot in the last 10 years, and usually it would be somebody that was an expert in that field, and then we come to the team and say, you have to do this and this and this, because I used to be a user and I know what the user needs. But those people, after a couple of years, they are out of touch because they don't know what the users need anymore because they are not the user anymore. And I think that we have come a long way to have that new wave of product management that is better understood, how to do product management. Now there's so many books on the topics and best practice and inspiration that it's made. Also the developer experience is more important. 10 years ago, if you had user and they make a mistake, you would say, read the fucking manual. Like, it's your fault. You're a bad user. You didn't use my software the right way. But now we come along with developer experience. We need to make things easier. People have a lot to learn, so we need to make things easy for them to learn. And I don't think anybody would say, no, read the fucking manual to somebody that is having a problem with the software, because we have understood the software has to be good enough for everybody.
That's like a sneaky little trend I hadn't even noticed come into play, that it really has changed, hasn't it? Like this whole shift of, if we're building something for developers, they're customers too, and we should treat them like that and build it to be, actually enjoyable to use and useful. Yeah, I like that. You work for Tyke. Can you just explain what is Tyke? What do they do?
Mm-hmm. Tyke is an API platform management. So we help our customers manage their APIs. And there's a kind of different use cases they come to us with. One is they have internal APIs, but they're all over the place. And they need to put standard governance, making sure who is able to access them, monitoring, add certain authentication mechanism, weight limiting, but also expose them, make sure they're being used, and learn again, are they really useful? Do we need to, who is using them? Are they useful? Do we need to deprecate them? So really get the whole APIs under control, and not like wild things, and then you don't even know that this team is using this team's APIs, but just like having a standardized approach to API management. The second thing is when companies start to see APIs as not only something to use internally, but something they can make money out of it. So exposing the APIs to the world for monetization. So maybe they have a product that they want to enable user to integrate with, or they want to sell data or integration. And then we help them push them to the outside world with the right security, also to make them available in a developer portal so that the developer can go to that developer portal, learn about the APIs, see the documentation. So that's the kind of second thing. And the third thing is a little bit more like integration. So sometimes you have APIs that have the right information, but they're not in the right format, and they are not really usable, but maybe you cannot change them because they're from an older system. So they can use Tyke, our API gateway and API management platform, to remove things, do some manipulation on the request, maybe remove some headers, or transform from an internal gRPC and expose them as a HTTP request. So, or teach two different APIs to expose only one to the customer. So all that kind of integration there.
Okay, so we talked about a week ago about what we might want to talk about, and you had this idea of talking about API-specific observability anti-patterns. And I guess I'm curious, how did you get onto this topic of API observability? Well, I guess you work for a company that deals with API, but that's probably one reason. But what is it about observability in that space, which is,
Yeah, so there's a story about it. So before joining Tyke, I used to work for an observability company. And so I come with a lot of background for observability. And when I joined Tyke, I saw the current approach and how we were, and there was the thinking, do we go to OpenTelemetry? It was like 1 year ago, a little bit more. And me coming with all my knowledge about observability, like, what? We could do this, we could do this, we could do this. So we started talking with customers, doing some research to understand their pain, trying to see all the feedback we had over the last couple of years. And we saw that there is a real trend in API observability, a real need to do things better. And what's really interesting in the API industry, that is a little bit behind in terms of observability. So people that build services, they're really aware of observability, but then usually there's an API gateway that manages your API, so that is in front. And there's a disconnect between the teams that are working on those API. And yeah, we saw the chance to do something better with API observability. And this is a topic that I'm currently working on with our team. And I think that's there's a real need, and it's time for better API observability. So when we started talking, I looked at your blog, Observability Antipattern, bad observability, and coming from the observability domain, I was like, yeah, that's this. And it started to map up in my mind all the topic that we were starting to discuss on the topic of API observability. And this framework of your observability anti-patterns helped me to put some of the thoughts in the right order to things that I see in the API industry. So yeah.
It's interesting that blog. I like the blog that I wrote, but I think my understanding of observability has changed. And actually, I feel like observability is a smaller thing than I thought it was. If I look at what's happening, so like in the OpenTelemetry space, and when people talk about observability, most of the time, they're really talking about like making distributed complex technology systems observable. I was thinking of it as observability in a bigger context, understanding customer experience and maybe how effective our team is going and what our processes are like and all kinds of things. So I guess that's been a shift for me, but yeah.
Things are still early. So there is what we know it's possible, but in every company, you can see that many companies are still early in the observability practices. And I'm with you. The end goal is like having really great data that you can make great decisions, but also based on end users. But still, distributed tracing is a thing where people are like, wow, that's really cool. And that's a technology that's already 10 years old. But now it's finally starting to be with OpenTelemetry to be open to everybody, to be more discussed about. But the technology itself, distributed tracing, is like 10 years old, so it's actually nothing new, but it's something that we need now, and that people are starting to get on board.
Yeah, I actually think the biggest challenge with distributed tracing is not so much the technical side of it. I think people can understand it and they want to implement it, but it's the way that most organizations are structured, and like politics, and the way that the teams are organized, that makes it really difficult. Because if you've got a really good design and you've sort of broken up your like problem domain into small manageable chunks that small teams can independently operate, easy peasy. But if you've got 10 teams that all need to work together and all their systems are tightly coupled together, and they've all got conflicting directives because there's different directors in charge of them, that's really hard to get everyone agreed to implement this thing. I think that's one of the real challenges anyway that I've seen in sort of like enterprise government organizations.
It's always the people. It's always the people.
Okay. So moving on to these anti-patterns, do you want to introduce your first API observability anti-pattern?
Yeah, so the first one is forgetting the users. And when you think in terms of APIs, if you expose your APIs, you actually have two different kinds of users. You have the first user is the developer, the one who is integrating with your API. And here, the data that you need, you want to understand how quickly they can use your APIs, if they're able to work with them. So it's kind of more of an API as a product approach, where we want to really know your API is a product that you put out. Your API is a product that you put out to the world, and you want to know, are people able to use it? And for the developer experience, you want to see at first, does the developer get some specific errors? Maybe you could check the errors and realize, they're always hitting that kind of errors because we have a bad sample, an old sample that we haven't updated that is still using something different. So it's, again, this whole end-to-end approach. It's not only, is my API reliable, but is it usable, and what do we need to make it really usable? And then, so this is the whole developer experience. And then after that, you have the end users of your user, because API is, again, kind of B2B product. So you're always selling it to somebody who is putting a functionality for somebody else. So the developer is integrating it, and then it goes to an end product, and somebody else is using the whole package. And again, you want to know, is it getting used more, or what is and sometimes you don't even know the impact that your APIs have because they're integrated in so many places. Maybe there's an outage or performance problem. You don't even know what is, and suddenly you get a notification, and maybe a really important website is down, or some information is missing because your API had a problem, and you didn't even know that it was being used there because you have the developer and maybe different layer in between. And so when people talk about API observability, they don't always match it with the user. They say, okay, this is our performance time, 95 percentile, 99 percentile. This is our error rate. But they don't always look at it on a user basis. And users make a lot of difference, especially when they're APIs, because they integrate it to different cases. Maybe you have user that you have specific contract with them, so you have to provide them better reliability, and other that are just playing. So you want to know what is the impact of your APIs per different kind of users.
I'm curious. So what if you've got an API which is used by different user groups? So, and those different user groups, we have different sort of levels of service that we're willing to provide them. So you've got your internal users who might use an address lookup, and it's like, it doesn't, we don't care if it takes long or whatever. But then you might have a really important bunch of external users, and we need to make sure it's really reliable and fast. With an API observability, would you attempt to differentiate between different kinds of users who are consuming the API, or would you just say, let's just pick let's aim it for the users who have the highest need and just make sure it's always that good?
It would depend who is your API for. If you have maybe 10 different customers, but a big integration, big customer, you might want to have observability for each of them. If you have more like hundreds, you might want to have specific categories. Maybe you have a different level of support of SLAs, so you want to be able where your SLAs for those different categories, for gold customer, silver customer. So I always have to think about who and how many users do we have, who are the most important ones. And also being able to spot which are the users that have the worst performance, then to be able to reflect why is that.
I'm guessing it's really important to have one of the dimensions that you need to include is who is consuming the service, so that you can differentiate. I mean, it's important in all observability, but I'm guessing with APIs, where I've seen APIs who are used by many different consumers for totally different reasons. It's important to understand which request is for who.
Yeah, and you want to know which are the one, like if you have many errors, and maybe that's okay, but for a certain customer that's not okay, and you need to be aware of. So it's always important to understand what are they doing with your APIs, and that's not always easy, because sometimes you put a service, but it's good to really have that understanding who is using your APIs, and that comes back to the product thinking, because if you're selling API as a product, you should have an idea or who are you going to sell it to. So you should have ideal customer profile. So you should know who you want to target. You should know how they're using it for, and then you're able to add better observability or to reporting based on those customers. But you really have to. It's not. I also have to talk. Engineers, sometimes we say, oh, it's just the software engineers. But when you work on a product, I've heard recently the term product engineer. So when you're a product engineer, you have to understand also the whole context. How is your software being used? It's not only a code, or it's understanding how does it fit in the big picture, and then you can make the most of it.
Okay, that's very cool. And I had a very similar anti-pattern around about for getting the users too. So I like we think the same way. What is your second anti-pattern for API observability?
So my second bad API pattern is API monitoring. So when you go to internet and you say, API monitoring, and you look for tools or reference or documents, most in articles at some point you realize, they're only talking about synthetic test of your API. So it seems like it was kind of, in the API world, it was kind of accepted that if you do API monitoring, you're just using synthetic tests to ask your API, are you there? Okay, you're here. Okay, uptime is good. And that's no, it's really I did a research on that, and I really looked so many research and so many websites, and it's always like, API monitoring is super important, and then you're like, okay, you're just doing synthetic tests, and synthetic tests can be useful, but it's just like you have to program them, so you have to say, okay, every 5 minutes, go send a request to my API with this exact payload. And of course, most of us will use a good scenario, so something that never fails, something that is easy, that you can reproduce. And then, okay, you have an uptime, and you can generate that nice graph to tell your customer, look, we are always green, our uptime is good, we don't have any issue. And so that's also similar to one of the patterns that you had on the lazy synthetic transaction.
Yeah. But yeah, so I was going to ask. I mean, I have a lot of ideas in my head, but so synthetic transactions. One of you just mentioned, one of the challenges, you actually have to build something, so you kind of have this asset which you now have to look after. So that's one thing. Second thing is, if you don't design them correctly, then it's just going to always pass no matter what, because it might not even execute any logic. It's like, what's the point? You're just hitting a health endpoint, the health endpoint of an API. Who cares, right? Another thing that really bothers me is the sample size. So you're like doing one request every, say, 5 minutes. There's not a lot of data points. It's really hard to see trends in reliability and performance over time, because it's just like a one now and again. And
maybe the integration part, that you don't have a real workflow. You just, like for an API, you just send that request, but usually. Maybe to have a meaningful integration with your API, you would have to have 2 different endpoints to pass information and to see how they work together. But it's not like a real end-to-end test. It's really just one request, and are you up, are you up, are you up? And that's not sufficient. I think people used to do that when they didn't have control over the machine, like black box monitoring. Okay, you don't have control, you don't see what's happening in there. Okay, try to make calls. At least you will get notified if notification is something is done.
The other thing that you miss out on if you just do synthetics is you're not actually seeing the workload and the patterns of behavior hitting your APIs. So you can't see at which times of the day is your API being hit the most, and what happens in those times of the day. and what are all the strange behaviors. And you don't even need distributed tracing to look at that. You could just look at logs. But if you just have synthetics, you miss that. So.
And I think another problem is that it's being done by a different team. So maybe those teams that looks only at API monitoring with synthetic tests, it's because they don't have access to the data. There's always data, but maybe it's again a people problem, organization problem, where the people that would need to monitor this API, they don't get access to the system where the information are. So they have to save themselves by coming up with a workaround. And for me, the workaround is those synthetic tests.
What you said before about testing an API in isolation, there might be a downstream system that's actually doing the execution, figuring something out, returning some resource, whatever it is. Yeah, that was a real challenge in the past of my career. So yeah, you'd have these big complex end-to-end systems, and so an API, you'd hit it, but it would actually trigger maybe 4 different systems, and you would depend, if you wanted to do an end-to-end test, on all 4 other teams to keep their thing up and running and all the data to be in sync with the right state and everything. And it's really challenging. But then again, when you start putting stubs or service endpoints to sort of mock that sort of behavior, then I think you also introduce a sort of level of risk, because you're estimating what you think will happen. And if you don't, I've seen doing testing like that where there's no delays. So you'll call an API and it will give an instant response. But then there's a whole category of risk around. But what happens if it's really slow and then a whole bunch of queuing occurs? You might run out of resources or memory issues and that kind of thing. So it's tricky, right? There's a balancing act between how painful end-to-end is versus you're kind of taking a bit of a stab in the dark if you put mocks or stubs.
Yeah, that's a good point. So mocks might be good for you starting developing, you want to have something, you want to see the teams, what you would expect. But then in testing, this has some limitation. And that's a good point. That's having something that is slow could have impact, and maybe you don't see it. We talked with a customer last week, and so they were asking, so they use our gateway to also proxy to external APIs that are not under their control, and they have the issue that one of those API that they call that they need takes sometimes 10 seconds to respond when they have an issue. So usually it's good, and at some point 10 seconds. And of course, the whole program is waiting for that 10 seconds till they can give an answer back to the user. So they're implementing something in our gateway to say, okay, if the API that I'm calling then takes more than half a second, then just return without anything else. Don't wait for the API, just continue without it.
That's given me flashbacks of the worst performance issue I ever saw, which was exactly the same thing. There was a mainframe system that was calling. Someone put in an API that calls to the cloud, and sometimes that took 25 seconds. But what they didn't realize is the mainframe system was literally single-threaded, and all the network requests that went out. So while it was waiting 25 seconds, everyone in the app, which is a core system everyone needed, couldn't even access its own database. It was just frozen. Yeah, it was so bad. Anyway.
To that, so the third one is thinking that logs or access log are enough. So we were talking about API monitoring. So in the API industry, when you look for API monitoring, it's mostly about synthetic tests. And now the API world has caught up with observability. So if you look for API observability, most of the time it's only logs and only access logs of your API gateway. Mm-hmm. And so I saw an article a couple of weeks ago from API tool, and they had API observability, and they would say also, we're just talking a bit, and by the way, there are metrics, logs, and traces, but then there were, so it feels like still very early, in the observability world, we have come a little bit, those 3 signals of observabilities are things that we're talking 3 years ago, 4 years ago, wow, metrics, logs, and traces. And now it's just happening now in the API observability. So you could see API observability, but fact is most people, when they use API or API observability, they really rely on logs, on the access logs. So to know, okay, who has called your API and what was the answer? Mm. And there's a couple of solutions that are based on API observability. So that what they would do is they would take your API logs and then transform them in some metrics, some dashboard. There's a couple of problems with that. One is there's no standard for it. So for example, at Tyke, we push our logs to different systems, and we have to do always that integration to change them to make it in a meaningful format for those observability API observability tools, which is a lot of work, like integrating with different. And I'm super happy that OpenTelemetry is getting more and more traction, because at least we have one format. We can export our data, and then every tool can integrate with us, and without having to talk to us, without having us to update an integration to make sure that the data is sent to the right, in the right format. And so most of the people still look at logs, the access logs, but the problem is, as you know, we live in a distributed world, and it's good to have a high level overview. Okay, how many people are calling my API? What's happening with them? But when there's an error or when something is slow, then you start a long process. So we have some teams that manage the API platform, the API infrastructure, the API gateway, that get visibility into those access logs. And then there is different developer teams that either integrate with those APIs, or that are the one who integrated, who are the one who write those APIs that are managed by the gateway. And so when there's an issue, typically those two groups of people, they have to come together, like compare their data, and then because they don't have this end-to-end distributed tracing. So this is why at Tyke is really important for us. OpenTelemetry is a big topic, and we are working on adding distributed tracing to our gateway, so that in the end, everybody can push the distributed traces into their system and really have that end-to-end picture. And so if something is slow, understanding is the gateway, is the configuration in the gateway, is it maybe a rate limit? Maybe the rate limit has been misconfigured, and then instead of accepting hundreds of transactions per second, we only are accepting one, something like that. Or is it the upstream service? And even we have a capability to integrate those different services and expose them as APIs. So it could be one upstream service that's failing, another one, or two of them, or one that is slow. And having that end-to-end visibility is really key to solve issue, because we don't want people to spend too much time trying to understand where is the issue. I think people should spend that time fixing the issue and not having to play detective with data.
In a nutshell, are you essentially saying that distributed tracing is really where we should be at, and access logs by themselves aren't enough because they're sort of siloed within one component?
Exactly, yeah.
Yeah.
That's a good summary.
I've been in situations where there was no distributed tracing, but we did have a correlation ID header in our requests, and so I would be getting logs from multiple systems and like writing code myself to parse them into a format, or put them in a database and then analyze them myself. And then, I had a colleague who wrote her own JavaScript libraries to render that in a flow diagram, because we didn't have any tools. And
so you wrote an observability backend, right? Kind of.
Yeah.
If you think about it, let's say.
Yeah, pretty much.
The correlation ID. I think that's what everybody ends up doing. That's why distributed tracing makes sense. That's what people want to be able to follow a transaction and understand what happens, and this ID is really key. There are a couple of problems with the ID. In the past, there were multiple different versions of those IDs. So there was the B3 from Zipkin, Amazon is using their own one, and now there is the W3C trace context, which is the new standard being used for OpenTelemetry. But customers still have older implementation all over the place. Or maybe they have an older trace ID implementation all over the place. Maybe they still have a B3 somewhere that is sending data, or maybe they have an Amazon load balancer that's starting the transaction, and it's not using the same standard, the same format of trace ID. So even here, there is still a little bit of work to do till we get this shiny end-to-end picture.
Could that be something that you could somewhat resolve in an API? But if an API has some logic in it, which says, if I receive any of these IDs, I'm going to create all the other headers that might be required with the same value or something. I don't know. I'm just...
Yeah, the problem is then in the observability vendors. So the observability vendors, when you send all the spans with those trace ID, they need to be able to stitch them together.
What about your fourth anti-pattern?
The fourth anti-pattern is working in silo. And so we see often, working in silos, different teams, different tools, different data. And that's a really important one for me, because I think the API is such a broader thing that has many touch points. It's just like a small service encapsulated. It's just managed by one team. APIs, it has implication for the API product manager that want to sell their APIs. It's from implication from the people that are building the upstream services the API is exposing. It's from the API platform team that is managing the gateway and the governance of the APIs. So you really, when you start talking of API, you kind of start talking about all the teams, and it has many friction points or connection points with different teams. And what we often see is that there are different teams and they work with different tools, which is okay. I believe every team should have some kind of ownership over the tool they use, and if they feel this tool is best for their job, personally, I think they should go for it.
I'm so glad you said that.
I like team ownership, value team, like they need to have what they need to work on. But then the problem is when they start to have different data, and then think about that example, the API is slow. And then they start looking in the tool with their own data point, maybe using access log of a gateway, and they're like, no, it's not us. And then the other team, upstream team, they look and say, yeah, something is slow, but it's not us. And it makes things so much more complicated.
I agree. I think that team autonomy and ownership over whatever their observability is, giving them the choice to pick what they think is best for them, is really important. But I would say that as long as every team is thinking about their monitoring and their logging and their tracing as not an internal thing that they can just do whatever they want with, but as a service or a product for the whole organization, because that's what it needs to be. So if you're going to use a tool that no one else uses, fine, but you need to do some things to make sure that anyone else that needs to access it can do that easily, like have the right information and there's the right guidance to do that. Anyway, that's my 2 cents.
Yeah, no, that's right. Like if autonomy is good, but it comes with responsibility, and you need to have teams that are mature enough to understand that. So it's not the Far West, but is autonomy with purposes. Yeah. What we see that is going to help is with OpenTelemetry, because once again, having a standard for data make it really easier to choose. Okay, well, think about an API gateway. You have this data, you can send it. You can send it to that observability vendor. You can send it to that observability vendor. And what's even great with API, so the API gateway is the component that manages everything. Every API, he sees everything, every APIs. And what we're discussing with our customers is that they have maybe one developer team using one observability tool and another development team using another one. And they both need the data from the API gateway, but then there's also a kind of governance or data protection that maybe the platform team don't want to send all the data to everybody. Could have some, first is a question of cost, because then again you have to pay for all the data points, but also data privacy or security. There might be some things that you don't want others to see. So what you could do with the OpenTelemetry collector is build those observability pipelines. And you can say, okay, for all APIs that have a span attributes like API owner is team 1, then send them to the observability backend of team 1. And everything that belongs to team 2, then send them to team 2. So every team can have the end-to-end, but only for the APIs that they are responsible for.
It might be a little unrelated, but I have seen situations where certain APIs have sensitive information, like customer information from production. And so the team who's responsible would just say, no one can look at these logs, for example. Does OpenTelemetry have the functionality built into it to help you filter out, say, customer information?
Yeah. So when you think about the OpenTelemetry collector, that's the component. You can, so starting back, if you take something that is instrumented with OpenTelemetry, you can either send it directly to an observability vendor, or you can send it to the OpenTelemetry collector, and there you can define so-called observability pipelines. So you could say, I want to take only the traces, but remove this and this and this, and and then that would be the case where you can just remove the attributes that you don't want this person to see, and then export to that observability backend.
Okay, so you can keep all the logs, but just take out the bits you don't want That's pretty cool.
Exactly. And that's so we did it already with many customers with our own proprietary instrumentation, because before OpenTelemetry was there, we had our own log mechanism where we can remove things and send to different tools, but we had to manage the integration, and many customers are doing that, because of course in the logs you always have things that you don't want other people to see. There's always auditing and compliance, so that's something that's super helpful.
So lucky last observability pattern for APIs, take it away.
Yeah, so it's not understanding that different API architecture style have different needs for observability. And what I mean for that, when we say APIs, we think mostly of REST API, right?
Of course. There's nothing else, right? That's it.
There's a lot actually, and there's more and more. So you have things like, you have the old school SOAP that we might remember from those from 10 years ago, where SOAP and web services were a thing, but more modern things like gRPC or GraphQL or WebSocket. So there's lots of different API architecture style that we call, and they have different needs for observability. So one example is GraphQL. Have you ever heard about GraphQL?
I've heard about GraphQL as far as I know. You did a conference talk about it at KubeCon, but that's about it.
Yeah, so GraphQL is a way to use APIs like database. So you have a kind of query language where you can, instead of just being very strict, like I send a REST request with this, and this is exactly what I get in every case. With GraphQL, you can have like a SQL query, SQL-like query language where you say, okay, I need from this data that you have, I need only the name and the last name, but nothing else. And that's been introduced. It started for front-end because, front-end mobile apps, they don't want to have too many traffic. So it needs to be super optimized, and being able to ask exactly for what you need and not getting more or not getting less and having to do round trip to get everything that you need is super helpful.
Would that mean that GraphQL APIs have a fairly high overhead in terms of needing to parse whatever gets thrown at them to figure out and translate that into a,
Yeah, exactly. So you have different steps with a GraphQL, and then behind your GraphQL services, you could have, again, multiple services. So the client just make call to the GraphQL endpoint. It's very good for developer experience. You can just ask the query, get the information back, and then you have your GraphQL server that is responsible for parsing and then figuring out how to execute it, and then get the data for the different services and then pass the data back. And for example, in the context of observability, GraphQL is over HTTP, and it will always respond with 200 status code, even if you have errors. So it's just like another level, but on the HTTP layer, you will always get 200. So if you try to monitor it like a simple, like a REST API, you would just like, oh, wow, everything is going great. I don't have any error. Because actually the GraphQL server, it's really interesting. They send back the error in the body of the response. So if you're a developer and you want to know was it successful or not, you have to parse the body of the response to know, there was error, and to learn about the error.
Yeah, that happens a lot in applications as well. 200 response, but there's a little error message hidden away in the body. Yeah, I've seen that before, that old trick.
Yeah, and then again, if you want to monitor your APIs and understanding how people are using them, then you might be full on thinking, wow, everything is going great, and I don't need to change everything. The developer experience is great. Nobody is experiencing any error. So you have to do a little bit more. And with my colleague Ahmed, we did a talk at KubeCon on using OpenTelemetry for GraphQL to get all those insights with errors. And we looked at the semantic convention. Do you know about OpenTelemetry semantic conventions?
I do. I'm not an expert, but I know about them, and they sound pretty good. Pretty great.
Yes. So the main reason of semantic convention is to have a common language on which field you put on your spans for which use cases. For HTTP would be like the response code, something that is standardized, and then the observability vendors, they can, okay, that's super important, and we can aggregate, and we can always use the same, and we know that no matter who is sending us the data, they will have the same format for those specific attributes. And so in the KubeCon talk, we looked a little bit at the GraphQL semantic convention. We're still very early, and there was nothing about error, so we are thinking of making a contribution to GraphQL semantic convention to add that concept of errors and to enable people to better monitor their GraphQL APIs with OpenTelemetry.
Thank you so much, Sonja, for coming on the show and sharing your first 5 bad API observability anti-patterns. I'm expecting a blog in the near future where you write about the rest of them as well. So I'm looking forward to that.
Yeah, I'll do that. It's a great idea, yeah.
And to everyone tuning in, thank you once again for listening to Slight Reliability, and I will see you all next week.
Thank you. Bye.